Hey everyone, welcome to the fifth part in the PongGDX tutorial series. So in this video, we're going to set up our Box2D world and also our first orthographic camera and a simple viewport just to get us started. I won't talk too much on the viewport code as that's not really my focus here, but in the next video, we probably will start figuring things out as far as like how we're going to be managing our camera and our batch or our sprite batches and our shape batches and how the viewport affects those. So anyway, let's jump right into the code. So if you remember, we have our game screen class that, as I previously mentioned, is going to house most of our gameplay logic. That's where the Pong game will essentially be running, and it's where players will be able to interact with each other and whatnot. So to get Box2D set up, we're going to need a few things configured first, and that'll include a orthographic camera for our Box2D debug renderer to work with. It will also include making sure that we have a Box2D world, and we also need to, I guess we could, as I said, like set the stage viewport. So let's get first the variables set up. Actually, we'll just be right here, and I'm going to extend this open. Open that constructor. There we go. Okay, and so up here we just need the orthographic camera, and we're just going to call this camera and import that. And then we're also going to have our Box2D variables, and that's going to include the world, and we're just going to call that world. It's kind of a easy name to pick. Import that, and then we're also going to have our Box2D debug renderer, and we're going to call that B2DR because that is a ridiculously long name and no reason to be exceptionally verbose for that. So now that we have our variables more or less set up for us to start using, we need to initialize them. So we have our camera equals new orthographic camera. Okay, and this dot camera dot set to ortho, and there's going to be some new things here. So first I'll just type it in. That's going to be v width application v height. Okay, and so what set to ortho does is it just kind of orients your camera to have a viewport, the orthographic viewport of we're setting it to the width and height that we have set in our application. And that's going to be our virtual width and virtual height, not the desktop or the desktop width or desktop height configuration. So just keep that in mind. This is where I'll be able to show you guys a little more how the differences between the desktop and the virtual width and height affect the way you set up your game and how that kind of scaling works. So when you create your application window a little bit bigger, you'll notice that it doesn't matter what the application window size is. Your game will always be in relation to the virtual width and virtual height. Also depending on your viewport that you apply to your stage and your camera. So other than that, let's also continue down, and we're going to have the app. Okay, so yeah, we have our camera set up. We also need to make sure that our batch and our shape batch are going to be rendering at the same coordinates that our camera is projecting on. And so we need to set their projection matrix, which is essentially like the view that they're currently working in, and like they render things with respect to our viewport that our camera is set to. And so we have app.batch.set projection matrix. That's going to be camera.combined. The combined is just pretty much the viewport matrix that we're able to see, and then we also have app.shapebatch.set projection matrix. That's going to be camera.combined. Okay, and so now the batch and shape batch are set up for future use, and now we can move on to our Box2D debug renderer and our world. So first we need to get our world set up. We have a world equals new world new vector 2, and I'll explain this in just a second. and false. Okay, so you'll notice that it takes an argument. This argument is the gravity force. So think of this, the X and Y plane, as like gravity force going down and gravity force going like left or right. So that could be like wind influence or something, or even if you're, I know there's a few games out there where the gravity changes, and I think there was like some kind of 2D Portal game where the gravity could change when you press a button, and so like your character would go to the top. This is something that you'd be able to modify, and so like if it was 9.8, a standard metric gravitational pull, and you can just flip it and it'd be easy as that. And so all gravity in your Box2D world would like flip in respect to the y-axis, or on the x-axis if you set it. But we are going to have it set to 0, and we'll see why once we start getting the paddle set up and the ball set up. Our ball is just going to be free floating, and it's going to have a constant linear impulse, or kind of a force that just gets applied to it when the ball starts, and that force should not deplete. So we're going to be doing some like normalizing on the direction of the ball, and that will get a little interesting, as you might already understand or have noticed. Box2D is a little bit more overhead than you might use for Pong. However, we are using it just to get a feel for Box2D, and I'm also going to be using some pretty interesting techniques as far as like creative ways to set up how we'll be playing this game. So I hope you guys enjoy that. I came up with some pretty good ideas and have Pong working pretty well, which I should show the project here within the next couple days or so. Of I think I'm about like 3/4 of the way through finalizing the project. I'm still working on the GL shader stuff. But anyway, so we have our world set up. This is gravity, and this is just whether or not objects sleep in the world. I normally set it to false just because we're not really doing any off-screen. Like all our world is going to be present on screen at all times, so we don't really have any off-screen sleeping objects like you might in a 2D platformer, where bodies will sleep if they're off the screen and wake once they are within a view projection. So next we have to set up our Box2D debug render, and so that's b2dr equals new Box2D debug render. Okay, thank goodness for autocomplete. So now that we have that, let's see. So this stuff will be created the second that we make our game screen in our game screen manager, and that happens in the init game screens. If you remember, we will pretty much initialize every single game screen and tag it with a state in our hash map. And so anytime you make a new screen with that in that initialization method, you need to remember like what you're doing in here has to be able to be set up. Otherwise, you're going to be doing a lot of initialization in the show, and like that's kind of where that other code would be, where you set up like the round, where if the screen gets shown, that probably means you're doing a fresh round, and so all the variables should be reset, and that's kind of what show has. Initialize will just have, or the public constructor will just have a lot of the larger objects created, so they're stored and you don't have to keep recreating them every time the screen is made. That way you're doing less work in your application. So let's see. So we have that. We need to make sure in our update method that our world will be updating with respect to our frames. And so that's typically like 60 frames per second. And to do that, you just have world.step. That's 1 divided by, let me think. So I'm pretty sure I have application dot, app FPS. So that'll give you the 1 over however many frames per second you're working with, and then 6 and 2. And so these numbers, they're kind of random to most people. However, it's pretty much telling Box2D how many like computations it should do in each of these frames for resolving collisions. And so the higher, the more calculations are performed. And these numbers have kind of been selected as the community's like happy medium. So just kind of stick to 6 and 2 unless you're doing very complex things that you don't really care if your game runs slower on any device. But these numbers will kind of keep you in your prime. So just resort to using those. Also in our update method, because we have a stage, we might as well get that set up with the act method. So anytime you introduce an actor to your stage, and every update call, the stage will update or send the delta and update all those actors. And then in the render method, we are going to have our b2dr.render. We pass it the world, and we also pass it the camera combined matrix. But because we have to scale it, we do have to do a little bit of an expensive operation here where we scale the camera by our pixels per meter. And that brings me to another point that I should introduce you guys to the pixel per meter thing. It's kind of along the same ideas as our like virtual width, virtual height, where we need to work with respect to the world that we're working in. So anytime you're using numbers in Box2D, they need to be in the world units. And then anytime you need to get those numbers out of Box2D, you have to kind of translate them back to screen units. And so the screen uses pixels and the world uses meters. So that's why we have this pixel per meter scaling factor, because we're taking the camera and we need to make sure to scale the camera by the pixel per meter. So like I normally use 32 pixels per meter because that's just what Box2D uses is meters. And so it's different than pixels. It's more so like world units, but it just makes sense to call it meters because it's a kind of real life physical calculations using like real physics to create this Box2D world. So to get that pixel per meter, I have created under just our root directory a new package called utils, and in that utils directory I have the b2d constants, and in here I have created a public final class b2d constants. Now most of you probably have never seen a final class, but with most final classes, you'll probably have a private constructor, if anything, if you're using for constants. And then you also want to have a public static float ppm equals 32f, or whatever your pixel per meter scaling ratio. It could be 10, it could be anything really. But Box2D works better with smaller numbers. So just keep that in mind. Like the smaller the numbers, the better efficiency it will run with. Like if you use just a flat 32 and didn't do any of this pixel per meter scaling, that means you're creating a 32 meter wide object, and that's actually huge if you think about it. So it's just better to use these smaller numbers, and that's again where we're going to be applying this pixel per meter ratio, is when we scale things down into our Box2D world and then scale them back up when we want to work on our screen units. And so now that we have this Box2D constants, we can go back to our game screen and we can do a static import. Static imports are a little interesting, but you just type import static, go to the package, Pong, utils, b2d constants, and then we're going to pull the ppm. Now static imports allow us to just call the variables as they are, so you'll notice this turned purple instead of red now, and I don't have to type b2d constants.ppm. This isn't something you want to do for tons of variables. I've mentioned this in other videos, and other people have come forward to me with like, well, why don't you just make it an interface? Well, an interface is nice, and you can, you know, implement the constants class, and that's all well and done. But if you have the choice to use static imports, and and all you're doing it for is just for like a simple variable like this, please do it that way. It just makes your code a little bit nicer on the eyes, and as far as like object-oriented design, it just makes more sense also as far as like looking at what the class is extending and implementing, because a class that implements a constants class, if you really think about like the design of that, it doesn't make a lot of sense. It's just, in my opinion, it doesn't really work. So we are going to be using the import static to get our PPM, and so we'll use that here to scale our camera appropriately for our Box2D renderer to work. So what this line kind of does is it renders with respect to our world, so it'll render what that world has, and then it will scale the world up by our PPM to pixel coordinates. So that's what the scale is for. If we divided by that, then it'd be scaling down again, which we don't want. So it'd be like scaling the world coordinates down further, which is worse. So we want to scale up to screen coordinates. So after that, we also, because we have a stage, again, just to get it out of the way, we're going to have stage.draw. That's a simple method call. That'll render any kind of UI or anything actors that we have on screen above the Box2D renderer draws. So let's see. Because we have our world now, we can look at this dispose method. Always remember to come back to that anytime you've done any kind of revisions and added things. So we have our world to dispose of, and I think really that should be about it. And so let's see, show is fine, and yeah, so if everything worked out right, we should still just get an empty world, but at the least we shouldn't get any errors. That's kind of what we're looking for right now. So I'll run the game, and once that's done, okay, oh, I forgot I left that red from the previous video. So yeah, this is looking just as we want it, except for the red. Let's go back to the game screen or abstract screen and change that back to some zeros for the GL clear color. So back to our game screen, we can close this B2D constants class, run that one more time just to really seal everything off to make sure we set it up right. Okay, so we got black. Good. I am going to go into the utilities class, or the utilities package. I'm going to go to make a new Java class, and we're going to call this, what to call this? So I think I'll call it like B2D bodybuilder. I might change that, but we'll just use that for now. So we're going to get rid of that. And what this class is going to be is it's kind of just going to be housing our Box2D body creation methods. Just for now, once we start getting into creating our entities for our game, we will just kind of house the creation of the bodies in those classes, because they should only be used for those specific entities that have bodies of that shape and whatnot. So with that, like I said, we should probably get at least a box on screen. So I think I'll show you guys how to do that real quick. We're just going to return a body, and so that's going to be public because we want to access this from our game screen, and we'll have body, or actually this is going to be static, so because this isn't a class that will instantiate, so it's going to be public static body create box, and we'll import that's going to be body from Bad Logic Physics Box2D. That's going to take a world because we need to create the body in that world, and then we'll give it an X and a Y, float, width and height, and I think that's all we need for now. So yeah, with that, let's just get at least something on screen. That's all we're really going for. So we're gonna have a body, and that's gonna be let's call it body, and we're also gonna return that body in case we want to reference it to remove it from our world or whatnot. But every body, as if you've seen any of my other Box2D tutorial videos, every body needs a body definition. And so a body definition kind of describes the physical properties of the body, and then you can apply a fixture definition to a body to describe the shape of the body, the density of the body. And so the difference between a fixture definition and a body definition is the body definition is more like, how does this body move in our world? Is it static or dynamic? What is the position of the body? Can the body rotate? And that's really about it. But the fixture is where you have the actual like physical properties of it. How dense is it? Is it a sensor? What's the shape of it? How does it look? How does it feel in the world? So let's get our body definition set up. So we're just going to call this bdef. We'll import body def, and that's going to equal body def, our new body def, and there we go. And so bdef, we're going to give it the body type of that's just going to be a static body for now. And then we are also, let's just not let it rotate. So fixed rotation equals true. That makes sure the body doesn't rotate. And then we can, after we've set up the body definition, you can see there's like a few other things, linear, like starting linear velocity, linear damping. Linear damping is like essentially how much friction or drag that the body has in the world. So like when it's moving around, how much does it slow down? And then linear velocity is how fast the body's moving. And whether it's active, that's that thing that I mentioned with the second parameter of creating a new world, whether it's like sleeping or not. And allow sleep, same thing. And then there's the angle. You can set the angle, angular damping, same thing with linear damping, except with respect to rotation. Position, which actually we do need to set that. The position is going to be set to, so that's going to be x divided by ppm, and we'll get that in a second. And then y divided by ppm. Okay. And so we need to do the import static com.Anderson pong utils UTD constants .ppm. Okay, we pulled it in. Good. And so with that, let's see, what else do I need? So to kind of, again, bring up that emphasis on making sure your numbers are anytime you're scaling to the Box2D world units from screen units. So because I'm just going to be entering like screen units as far as my x, I'm not going to be thinking about in like float decimal places. That'd just be too hard for me to think about. I'm just going to say like, okay, put it at 0, 0, or put it at screen coordinates 100, 100. That will put it on the screen. Probably like if I said 100, that would be 100 meters. So again, that would be like way out of our view. And so we have to scale it down to world units from screen units. So anytime you're going from screen units to world units, you divide. Anytime you're going from world units to screen units, you multiply. So just kind of watch that pattern as I go. Anytime I pull these numbers or input these numbers. So yeah, with that, we can do body equals new, or actually, no, not new body. It's world.create body, and then we pass it the body definition. And so now we've just created our first body. It doesn't have a shape. It doesn't really do anything yet. It doesn't have any fixtures on it. And fixtures define what the body looks like. So let's get our at least our shape set up. So we're going to have a polygon shape. Shape equals new polygon shape. Okay. And then that shape is polygon shapes come with a pretty nice method called set as box, and that just takes a height and width again with respect to world units. So we have to do width divided by 2 and divide by ppm. I'll explain the divide by 2 in a second. And then height divided by 2 divided by ppm. Okay. So what Box2D also works with for their fixtures is it always works from the center of the body. So if you want an absolute width, like of the full width of the box, let's say you want a box that's 4 units wide and 4 units tall, it's going to do it from the center. So if we just said width without divide by 2, that would be 8 units wide. And so you can kind of see like it'd be 4 units from the center and on both sides. So that would count towards 8. And so that's why we divide it by 2 to get the actual width of what we're looking for. And same thing goes for height. So now that we have that, we have our fixture def that we need to set up. So fdef equals new fixture definition. Okay, import it. And so fdef dot shape equals that shape we just made. So we're setting the fixture definition shape for our body that we're going to be working with, and then we'll give it a density just because it might even default to 1, but just for the sake of having it in there for you guys. Fdef, you'll also see there's the friction of the body, the restitution, which is kind of like the bounciness of the body, filter, which I'll cover later on, that's for like masking and whatnot, and the shape, which we already set, and is sensor, which is so you can use a like world contact listener to watch for like a body that goes into a goal, for example. Hint hint at a future thing we're going to be using for our pong ball and scoring. So we're all done here, and we just have to set the body's fixture. So body dot create fixture, and this is where it creates the shape fdef. All right, and so now that we're done with using that fixture definition and the shape, it's always good to dispose of the shape when you're done with it. So dot dispose. And so with that, this is kind of a standard Box2D body creation method that you might see anywhere. Even in my tutorials, I feel like I have really used this across all my projects. It's just kind of the standard getting started method, and then from there you'll probably add variables in here or parameters to the method and do more things in here while like anytime you create a body. So now that we are done with the B2D body builder, create a box method, we're going to go to our show method, and we're going to do so we'll have Box2D. This is going to be body box. We'll just call it box for now. Remember, this is all just proof of concept stuff. So we're getting started little by little. So box equals that's going to be B2D bodybuilder dot create box. We'll pass it the world, and we'll set the center as 0, 0. We'll give it a height and width of, how about like 8 by 8, and I think that was all we needed. Yeah, okay. So with that, once the game screen is loaded, it will initialize it in the game screen manager here. It'll set the screen of the main application down here in the set screen method, and then once it sets the screen, it'll call this show method, and then in the show method, because the world is already created, we will create a box body, and it'll start going through the update and render, update, render, update, render loop. So let's run it real quick and see what we got. See if we hit any bugs along the way. Okay, you'll notice down here there's some green green lines there. This is because our camera is kind of what we're using to render our Box2D renderer, and 0, 0 is considered the bottom left corner. So we need to set this the position a little bit differently. So this is going to be camera dot viewport width divided by 2, and then we're also going to pass it camera dot viewport height divided by 2, and that should put it in the right spot for us, I believe. Okay, yep, there it is. So there's our little box that we created. It is only 8 units by 8 units. It is not even 1 meter. And so if we did like 32 by 32, that would give us 1 meter in our Box2D world and 32 pixels on screen. Just kind of the standard for like a sprite width and height. And there you have it, guys. So with that, we have our Box2D world up and running. We don't really have anything going on just yet, but in the next video, we will hopefully start looking at some more camera work and getting our stage set up with a viewport. And from there, we will start working on the Pong kind of this area. So we'll get everything set up. We'll have our paddles. We'll have a ball moving. And from there, we should be good to go and start working on like more UI, getting interfaces set up, and getting our entities created. So with that, hope you guys enjoyed the video. Like, comment, subscribe as usual, and I'll see you guys in the next one.